Hello. In this video, we are going to discuss about a special type of integral known as the Gaussian integral, which actually looks something like this. Today, we are going to solve this particular integral by actually not by using the classical methods of integration, but by using a particular function called the gamma function. Okay. Now, starting with this, over here, we can notice that this particular function is actually an even function, which is symmetric about the x equals to 0 point. This is always obviously clear. It's obviously quite clear because the actual value of x, whether that it's positive or negative, that doesn't matter because it is x squared. So it has to be symmetric over x equals to 0. So it's an even function. So we can simply change this integral, not change the integral, but we can just change the limit from 0 to infinity, e to the power minus x squared dx. And we are just multiplying it by 2 because it is symmetric about x equals to 0. Moving on. Now we are going to define the gamma function. Now what is this gamma function actually? We define this gamma function by, we use this particular symbol, which is the gamma symbol in the Greek alphabet. And we define the gamma function as the following. This is the integral from 0 to infinity, t raised to the power of minus x minus 1, e to the power of minus t dt. Fine. So this is the integral. Now we're going to define some properties of this integral. This is a very important property. This is actually the gamma function's property, and this is what makes it so much useful. And actually we're going to use this particular form in order to solve this. From here, we can also write that if we multiply n with gamma function of n, we'll get n times n minus 1 factorial, isn't it? So this will actually be n factorial. Fine. So n times n minus 1 factorial is n factorial, isn't it? Now, coming back to this in particular integral. Over here, we're going to replace x squared with t. Now, if I derive both sides, differentiate both the sides, we'll get 2x equals to dt over dx. So we can write dx is actually dt over 2x. Now, if we replace x with t, we can write that x is actually equal to root over t. So we can write that dx is nothing but dt over 2 root t. Now, we're just plugging in the values of x over here. So this will give you 2 times the integral from 0 to infinity e to the power of minus t dt over 2 root t. Now we can cancel these 2's and finally get an integral which is like this, t raised to the power of minus half e to the power of minus t dt. Now if you look very carefully, isn't it looking somewhat like this? If you see this particular integral, if we replace x with half, this particular integral will turn something which looks like this. Half minus 1 is minus half and e to the power of minus t dt, which is exactly this particular integral. So we can say this. Now we have got something which can actually help us to solve this integral. Now we are going to use this particular property. Fine. Now, another thing that we are all known with, that gamma function of 3 by 2, which is actually half factorial, is root over pi by 2. This is known. This is known. We know this. Fine. So in fact, we can say the gamma function of half times half is actually half factorial because it is over here. This one actually. Fine, isn't it? So you can say that half times the gamma function of half is half factorial, which is root over pi by 2. In fact, we can cancel out this 2. finally get that this particular integral, which is actually this one, is exactly equals to root over pi. So we can write that the integral ranging from 0 to infinity e raised to the power of minus t raised to the power of minus half dt is equal to root over pi. So this, we all know that this is actually, okay, I made a mistake. When we're defining these limits, we can all these values are always equal to x. This is actually the values of x, not is of t. This is not of t. This is of x. Fine. These values, infinity and 0, these are the values of x, not of t. Fine. So this is exactly equal to the first integral that we had defined, from negative infinity to positive infinity, e to the power of minus x square dx. So we can write this is actually equals to root over pi. So this completes the proof. So over here we have seen that without using any classical concepts of integration, we have used the gamma function to find the exact solution. Thank you everyone.